Okay, my name is Keming from Brunel University of London. This is a very recent work with my former PhD student visitor and my former previous boss, Professor M.C. Jones. The title is a General Family of Quantile Regression and Coherent Risk Measure. So from the title, you can see we are going to talk about we're going to introduce a general group of regression, which including conditional or classical quantile regression and other regression, and also including many popular coherent risk measure. Why we want to do that? There are several reasons. You can see from previous talk, quantile regression is very useful for different fields for many of application. Also, modeling, regression modeling, distribution, heavy tail distribution, asymmetric, and deal with outlier, and so on. Have attracted a lot of attention in literature and research. Coherent risk measure has been an important mathematical tools in financial risk management and so on. So let's maybe briefly its motivation. I'm going to brief what we have done so far. The paper is quite longer, just finished, but we don't have time to talk about too much mathematics. But I just introduce base idea and the some of the new result.
Okay. So during the summer, I was just working with elliptic convolutions, but then I actually continued working on the project. And I gave it one.
Okay. So the quantile regression definition, I don't need to repeat. Previous speaker have introduced already. Quantile regression can define in terms like this way, and also can be estimated in terms of a loss function, this check function, specific check function in terms of tau. Tau is a quantile level between 0 and 1. This everybody knows that. Quantile regression have a direct link to the typical risk measure in finance, like valued risk, which can define in terms of quantile regression. But valued risk overall is not a coherent risk measure. Coherent, and maybe everybody here know what that means, you know. But also then people in risk management introduce expect shortfall. Expect shortfall also linked to quantile regression, which can be defined in terms of integral like this minus 1 over tau, integral from 0 to tau, and over conditional quantile function. So this expect shortfall, unlike var, is coherent risk measure. So that's the difference. And also recently we have seen a lot of other, risk measure and regression beyond mean, like expector basic, the var, which is defined in terms of expector regression. This is expector regression definition. Okay, and then like tau level basis, the weighted the quadratic loss function. So that's the defined expector regression. Based on the expector regression, people can define expector var. Okay, this is the regression and when the finance risk measure both linked together. Moreover, recent year, like people introduce extra miles, is defined in terms of the quadratic loss function, weighted loss function, weighted quadratic loss function, and that's the reference paper below. So let's see what we have seen there. All this quantile for expected regression and extra miles, they are they have common feature, can be used to measure heavy tail, extreme case against outlier or not, and then so on, okay? They have a common objective, but they are performed differently, okay, for different reason, okay, different motivation. So that is about the work, but there are some issues with existing work. For example, quantile basis of object function, as you know, is not smooth due to the check function. So even the underlying quantile function is continuing. And another thing is the derivative of the objective function in the classical quantile, it doesn't exist, and then could have a problem to non-unique solution based on the minimization method check function. Moreover, symptotically or theoretically, and you may want to see the symptotic normality of the standard quantile estimator, which depends on the behavior coverage expression or presentation, which sometimes the conversion rate is not so good. Okay, for some recently we can say many people published the smooth version of the quantile regression towards this sort of issues, and in classic quantile regression, which including like other Myers and other regression we are going to talk about more later. This is some of motivation. One more motivation, we recall the generalized linear model. We know, can unify the meaning of the mean regression, okay, through the link function G. But the generalized linear model, GLMs, may not contain or including like regression beyond the mean, like quantile regression, expected regression, and so on. Okay. So the current work we are doing may provide a uniform structure or the framework to unify many of the regression model beyond mean. Okay. So what's the definition of the regression we propose? This is one. We like quantile regression, we have the tau. Tau is between 0 and 1, is quantile-like level, quantile level, okay? The conditional tau generalized quantile regression is defined in terms of this integral. So we define as C tau of y given conditional x equal integral between the 1, the integral over s level. This S is inside is quantile, conditional quantile. The S is between 0, of course. And this J tau S is a function of S, and in terms of the quantile-like level tau. So this is the general definition. Later we demonstrate how to choose this this weighted function J tau S. Okay. What sort of condition this J tau S should satisfy? Okay. Before that, we point out by choosing different J tau S, all existing regression beyond mean could be special case of this G tau Y given X. For example, from this table, the classical quantile regression, if you choose this G tau S, it's like this usually the function, okay, like this one, delta S minus tau, okay, then this Chi tau Y given X reduced to classical quantile regression. The expected for regression, or could be chosen by J tau S as this case. And recently people propose like exponential spectral risk measure could be special case if you choose J tau S as this. And experiment regression could be a special case if you choose G tau S with this. And the rest of the people provide something like a weighted average quantile regression could be a special case if you choose G tau S like that. So that's the C tau Y given X, including many of recently regression beyond mean, and also the classic one. Okay, this is special case. What's the condition? The weighted function J tau S should satisfy. This is we call condition of C1. So first, of course, this weighted function must be positive, non-negative, for all tau and S. Must be normalized between 0, 1 to 1, like a density function. Must be satisfied the revised property and the monotonic property and so on in terms of S. So this is condition 2. Also is a non-increase for the half range of tau and non-decrease for another half range of tau. And condition 3, this integral between 0 and u with respect to tau is a non-increase function for all u between 0 and 1. So this is a condition C1 we require for the weighted function, right? Okay. So then we can see why we need this sort of condition. For example, the condition 1 is understandable because it must be like a positive, for that range. The condition 2 is used to guarantee the coherent property. Later we can check that. Okay, we want to make sure this general family, including a lot of recently risk measure. So this is the guarantee coherent property. Okay, so this is one we need to record. Conditional 3, including the C tau Y given X, is non-decreasing with respect to tau, which means like avoided the like quantile like curve crossing problem, but no crossing, Okay, this is guaranteed. So based on this sort of this condition C1, then we have a general result, like, we have theoretical result, let Y given X of some standard assumption, like first moment exists, and the weighted function satisfy condition when we just mentioned, then we can prove this C tau Y given X definitely exists. And also this one is a non-decrease function with respect to tau, which guarantees the curve under the C tau Y given X. There are no quantile crossing issues, okay? Also we have a lot of other monotone or issue, the solution for the non-crossing issues, okay? Number 3, if the conditional deviation Y given X is symmetrical, which is special case, then we can prove this C tau Y given X in terms of the conditional mean. It's in some sense, it satisfies the this formula, which means the low and up general quantile regression curves are symmetrical about the conditional mean. Okay, so this is another property we can find out. Moreover, if the underlying regression Y in terms of X is given by this formula, and then we can also derive the C tau Y given X satisfies similar formula. Okay, so that's that. Moreover, if we multiply this omega tau to C tau Y given X, then the together is coherent. Coherent, which means this satisfy these 4 properties of coherent requirement, which indicate this can be used or introduce a lot of new coherent measure in finance. So let's look about a special case, okay? Recall expect shortfall, which equivalent. The weighted function is given by that. This weighted function equivalent uniform density between 0 and tau. So if we generalize this expect shortfall by generalize this weighted function with this one in terms of A is non-negative constant. A equals 0 reduced to expect shortfall, then we can introduce new coherent risk measure. We can prove with different A will have different property or different curl look like, that's one. Particularly if you choose A equal 1, and you can see which is decreased linear density on the range. So that's weighted in that range. And we can work out the different quantile level, level of the new risk measure. Okay, this is well, we did draw different picture in terms of different A. We can find some differences, which is measure tail or extreme case slightly difference, and even better. So we can choose different A. I don't need to investigate the detail how to derive that. And then we look about the existing recent work. People work on the extra miles. So we can generalize this because extra miles could be special case if we choose J tau S like this. Okay, which equivalent this J tau X is beta density. Beta have 2 parameters, these 2 parameters in terms of tau. So if we generalize this beta density by this one plus alpha tau, this alpha tau could be any values, okay, satisfy the beta distribution requirement. Then extra miles is special case with this special alpha tau. So so that means extra miles regression or risk measure is a special case of this general family of quantile regression or C tau y given x. Right. And there are a lot of property we can study under this topic. I don't want to go to detail, right? So we choose a different alpha tau anyway. You can get different of measure. You get a new regression and a new risk measure, or the new risk measure also and coherent. Okay, so that's we can compare different type of. When I choose a different type of alpha tau, we have different curve, and we can say they have different performance in the tail and so on. So this is about that generation. Another generation, when people are talking about this paper, talking about exponential spectral risk measure, we can generalize as well. We can regard ESRM as a special case of our model. So if we choose this, then this model reduced to the case, and then we can generalize them by introduce a new weight in terms of alpha tau, okay? And the case is a special case, alpha tau equal minus log 2 tau, okay? So let's say we can generate a lot of risk measure, okay? So they just study some of the properties. We have 5 minutes, right? Okay. Generally, you can anybody based on this model, you can introduce many new coherent risk measure. For example, we take a truncated Cauchy distribution as a start point to derive a new risk measure. For example, yeah. If we choose weight relative to that distribution in terms like that, and then we can get a new coherent risk measure, which we have a detailed analysis which makes sense, which is different, which sometimes performs better. Okay, later we have simulation. Right. We just demonstrated the coherent risk measure in terms of different generalization. So in terms of tau and so on. Right. Maybe I show some of the numerical simulation result. So mathematically, generally, we can prove if we fix the tau, we can order the coherent risk measure. Okay, we have this. We can prove generally we satisfy for fixed tau, which is the biggest one, which is the smallest one, and what's the order of this new or existing risk measure. So we can prove that in generally. Okay, so that's the one important result we have. Then give financial risk measure research choice. So depends on what they want to do. Again, they focus on the extreme tail, or they focus on the middle, or they want to measure different part of the risk distribution or so on. So depends on that. This is about the result. Then we come to the important question, how to estimate this regression. So to estimate regression, we rewrite the C tau y given x into equation 6 from equation 1 before. Then you can see these two inside of two integral contain the conditional distribution f. So then we just focus on the estimation of f. Any estimation of the cumulative distribution or dividing function f would be
bad luck. This is life. I did nothing. I think it's a problem of connection. Side, no? Yeah, it's from inside connection, I think. Yeah. Okay. Yes. Connection was lost, but anyway, can you conclude now?
Oh, okay, I'll conclude. Okay, this is some total result. Then we did some simulation. Simulation show our new measure or new regression.
You're not sharing.
Yeah. Okay. Anyway, this
you are not sharing your screen.
Yeah, this article introduced a novel non-mean regression beyond mean and a group of the coherent risk measure. That's all. Thank you for your listen.
Thank you.
Thank you.